Hello everyone, I'm Wang Yuxiao. It's a great pleasure for me and partner Japan to present our project. The title is Wide Area Cellular Networks. Our presentation will be divided into the following 6 parts. The first part is introduction. Employing information and communication technology creatively and efficiently to boost the global economy is becoming more and more crucial. In the past 2 decades, the internet has centered on the internet of people. With fixed line broadband, people can access the internet through PCs, realigning the connection between the first generation of people and the network. Since then, mobile networks has continued to iterate and improve. And the 3G and 4G networks allow people to access the internet through portable mobile devices, realizing the second generation of connection between people and network. From second generation mobile communication system debuted in 1991 to the 3G system first launched in 2001. The wireless mobile network has transformed from a pure telephony system to a network that can transport rich multimedia contents. The 4G wireless system was designed to fulfill the requirements of international mobile telecommunication advanced using IP for all services. In 4G system, an advanced radio interface is used with orthogonal frequency diversion multiplexing, multi-input, multiple output, and link adaptation technologies. There are still some issues such as spectrum crisis and excessive energy consumption that even 4G cannot address considering the proliferation of wireless mobile devices and services. The need for high data rates and the mobility demanded by emerging wireless applications has been challenging wireless system designers. In order to solve this problem, people began to develop 5G. And compared with the 4G network, 5G will have the following advantage: fast data transmission rates, high frequency utilization rate, strong wireless coverage capability, the good compatibility, low cost, and not subject to site restrictions. 5G networks expected to enable a wide range of new applications and services, with 3 major application scenarios being particularly notable. First is enhanced mobile broadband, second is massive machine type communications, and last one is ultra reliable low latency communications. Enhanced mobile broadband is the first major application scenario of 5G networks. With 5G, EMBB will provide users with fast download and upload speeds, enable more reliable and stable connectivity for applications that require high bandwidth. And MMTC is the second major application scenario of 5G, with the ability to connect a vast number of devices, and 5G enables the development of the Internet of Things and industrial the industrial Internet of Things. Last one, the UILC is the third major application, and which is designed to provide high reliability and low latency for applications that require real-time communication and will have a significant impact on the industries such as healthcare and transportation and public safety. The second part is the development process of 5G communication. In February 2013, the European Union announced that it will allocate 50 million euros to accelerate the development of 5G mobile technology and plans to launch a mature standard by 2020. And in May 2014, The Japanese telecom operator officially announced that it will cooperate with Nokia, Samsung, and other 6 manufacturers to start testing a high-speed 5G network that exceeds the network carrying capacity of existing 4G network by 1,000 times. And in May 2016, the first global 5G conference was held in Beijing. The conference pointed out that the development of 5G has become the strategic consensus of the international community. 5G will greatly improve the service experience of mobile internet users, meet the massive demand of Internet of Things application, promote a major leap in the mobile communication technology industry, drive the rapid development of chips and software. And in June 2018, the 3GPP 5G NR standard SA solution was officially completed and released at the 18th TSGRAN plenary meeting of 3GPP, which marked the official release of the first truly completed international 5G standard. The final version of the 5G standard R16 was completed in 2019. The types of technology which research and development effectively promotes the development of industrial technology, which is of great significance to the promotion of a global unified 5G standard, marking the arrival of the 5G area. The third part is influence of social economics. Cellular IoT communication module products are widely used, and the scenario includes smart cities, smart agriculture, vehicle networks, industrial application, smart internet, and other networking scenario of various things. In terms of energy management in smart cities, the main solution is the intelligence of and the automation of energy use management maintenance, especially including smart meters, smart water, smart gas meters, smart heat, smart street lights, and other related applications. In terms of application of the Internet vehicles, injection of communication module has released the all-around network connection in the car. Between cars and road, between cars and people, and between cars and service platforms, improving the intelligent level of cars and the ability of automatic driving to build a new format of automobile and transportation services. In terms of smart internet access, especially since the birth of the nuclear epidemic, a stable and high-speed network has become an urgent need for people to work and study at home. The development of 5G communication technology has solved the last mile of optical fiber access. Internet terminals integrated with 5G communication modules, integrated 5G internet access computers with high performance function can make up for internet access demand, which has become the large application scenario of 5G cellular modules. In terms of industrial internet, IoT technology is the base of the transformation and upgrading of the industrial manufacturing industry. The new type of industrial internet breaks the traditional information island and drives the double improvement of manufacturing and services in the entire industrial chain and value chain. Cellular modules introduction of it can solve the problem of logistics distribution, major site supervision, marginal production quality supervision, and enterprise production data. In terms of the application of smart agriculture, China's agricultural digital technology has developed rapidly and has been in the stage of running parallel with developed countries in terms of agricultural remote sensing and agricultural machinery navigation. By integrating 5G, 4G cellular communication modules, big data, cloud computing plays a full role in agricultural production applications, realizing various applications such as unmanned farming of agricultural machinery, independent fertilization of crops, animal health supervision, and unattended animal breeding, so that the rural reflects the power of high technology.
Hello everyone, my name is Yao Zhipeng. I will take charge of the remaining part of the presentation. Then comes the fourth part is technical analysis of 5G cellular networks. In this part, we will introduce from three perspectives: communication module, modulation method, and key technologies. We first from the communication module. Its hardware mainly includes baseband processor, RF transceiver, RF front-end transceiver module, power management unit, and memory. The baseband processor is the core of the module and the central processing unit of the whole module, providing wireless protocol encoding and decoding, and controlling the work of each sub-function block in the module. The radio frequency transceiver is the abbreviation of the combination of the radio receiver and the transmitter, and the receiver and the transmitter are usually combined. It is a chip. The main function is to convert the digital signal sent by the baseband chip into the radio frequency signal sent wirelessly, and convert the radio frequency signal received in the air into a digital signal. The power management unit is the internal power supply of the module. The management of the module provides energy for all electronic components in the module, and its internal architecture is shown in the figure. 5G communication modules involve more than 1,000 electronic components and more than 200 categories. Over-the-air cut, multi-slice integration, communication power integration, low power consumption, and low latency and low power consumption. And I will introduce several of them next. Network slicing is an important feature of 5G. Specifically, network slicing is a collection of network functions with specific wireless configuration and transmission configuration, which can provide operators with multiple end-to-end virtual networks on the same set of physical equipment. In the network, a slice supports the logical function of a specific use case. With the construction and popularization of 5G networks, power consumption has always been a topic of concern to everyone. The power consumption of terminals, base stations, and other equipment has been greatly increased, so the green network technology that reduces terminal power consumption is also a key technical point. For receiver, let the UE enter the sleep state periodically to reduce power consumption, using signaling to perform hot reporting to reduce terminal high-level capability loading and reduce power consumption. And we can use APT and ET to realize automatic tracking of module RF power and adjust the module's emission. In the base station, according to the number of service users and data bandwidth, some stations are shut down and the number of transmitting antennas is reduced to reduce power consumption. Okay, let's look at the modulation method. I present orthogonal frequency division multiplexing, OFDM, is a widely adopted solution mainly because of its robustness against multi-pass channels and easy implementation based on FFT algorithms. However, the anticipated use cases for 5G networks have difficulties that OFDM can only partially solve. Additionally, the high out-of-band OOB emission of OFDM poses a challenge for dynamic spectral access. A flexible multi-carrier modulation technique called generalized frequency division multiplexation, GFDM, has also been proposed for the air interface of 5G networks. The versatility of GFDM allows it to encompass CP-OFDM and single carrier frequency domain equalization as special cases. By this method, OOB emissions are reduced, enabling fragmented spectrum and dynamic spectral allocation without significantly interfering with existing services or other users. Considering the block diagram as expressed in the figure, a data source provides the binary data vector B, which is encoded to obtain BC. A mapper maps the encoded bits to symbols from a mu power of 2-valued complex constellation, where mu is the modulation order. The resulting vector D denotes a data block that contains n elements which can be decomposed into k subcarriers with m subsymbols each. The total number of symbols follows as n equals to km. Therein, the individual elements dkm correspond to the data transmitted on the k subcarrier and in the nth subsymbol of the block. Each GKMN is a time and frequency shifted version of a prototype field Gn, as shown in this formula. The GKMN is a circularly shifted version of GK0n, and the complex exponential performs the shifting operation in frequency. The transmit samples x equals to xn transverse are obtained by superposition of all transmit symbols. We collect the filter samples in a vector GKM equals to GKMN transverse allows to formulate this, where A is a Km multiplied by Km transmitter matrix with the structure according to A, like this formula. At this point, X contains the transmit samples that correspond to the GFDN data block D. Lastly, on the transmitter side, a cyclic prefix of NCP samples is added to produce X. Transmission through a wireless channel is modeled by Y equals to Hx plus omega, where Y is the received counterpart of X. At the receiver, time and frequency synchronization is performed, yielding Ys. Then the cyclic prefix is removed. Under the assumption of perfect synchronization, the cyclic prefix can be utilized to simplify the model of the wireless channel to Y equals to Hx plus omega. This allows employing zero forcing channel equalization as efficiently used in OFDM, although other equalization processes can be employed. The overall transceiver equation can be written as Y equals to HAD plus omega. The linear demodulation of the signal can be expressed as D equals to BZ, where B is a Km multiple Km receiver matrix. GFDM has several advantages over OFDM, including the ability to operate in non-contiguous spectrum, which makes it suitable for use in cognitive, radio, and dynamic spectrum access systems. GFDM can also support low latency communication with high reliability, making it ideal for applications that require real-time communication, such as industrial automation, virtual and augmented reality, and autonomous vehicles. And then we will introduce key technologies of 5G. In this section, based on the above proposed cellular architecture, we discuss some promising key wireless technologies that can enable 5G wireless network to fulfill performance requirements. The purpose of developing these technologies is to enable a dramatic capacity increase in the 5G network with efficient utilization of all possible resources. And we will introduce massive MIMO, cognitive radio networks, and mobile femtocell. MIMO system consists of multiple antennas at both the transmitter and the receiver. By adding these multiple antennas, a greater degree of freedom in wireless channels can be offered to accommodate more information data. Hence, a significant performance improvement can be obtained in terms of reliability. spectral efficiency, and the energy efficiency. In massive MIMO systems, the transmitter and receiver are equipped with a large number of antenna elements. Besides inheriting the benefits of conventional MIMO systems, a massive MIMO system can also significantly enhance both spectral efficiency and energy efficiency. Furthermore, in massive MIMO systems, the effects of noise and fast fading vanish, and the intracellular interference can be mitigated using simple linear pre-coding and detection methods. The CR network is an innovative software-defined radio technique considered to be one of the promising technologies to improve the utilization of the congested RF spectrum. CR's receiver should first monitor and allocate the unused spectrums via spectrum sensing and feed this information back to the CR transmitter. A coordinating mechanism is required in multiple CR networks that try to access the same spectrum to prevent users colliding when accessing the matching spectrum hosts. In interference-tolerant CR networks, CR users can share the spectrum resource with a licensed system while keeping the interference below a threshold. The MIF femtocellular is a new concept that has been proposed recently to be a potential candidate technology in the next generation intelligent transportation system. It combines a mobile relay concept with a femtocellular technology. An femtocellular is a small cell that can move around and dynamically change its connection to an operator's coordinate network. It can be deployed on public transport buses, trains, and even private cars to enhance service quality to users within vehicles. Although there have been some developments in the 5G wireless technologies, there are still many challenges ahead. Due to the limited space in this section, we only discuss some of these challenges. For some common 5G situations like huge MIMO channels and high mobility channels, realistic channel models with proper accuracy complexity trade-off are essential. As many antennas may witness various sets of clusters cannot be directly used by conventional MIMO channel models. Massive MIMO channels differ from traditional MIMO channels in a number of ways, including the spherical wavefront assumption and non-stationary features, which should be considered in massive MIMO channel models. Moreover, 3D massive MIMO models are more complex but more useful because they simultaneously account elevation angles. How to effectively and reliably manage the mature interference of CR and primary system in 5G interference-tolerant CR networks is another significant challenge. To cohabit with other permitted systems, the transmit power must be regulated for the CR system. For this reason, an interference temperature model is presented to describe the interference from the CR to the licensed network. To reduce the interference at CR receivers, interference cancellation techniques should also be used. Another problem with this is the necessity of a feedback mechanism to periodically update the CR network on the interference situation at the licensed system. In addition, the application scenarios of the Internet of Things are complex and diverse, and it is difficult for a single technology network and a system to provide all services. Therefore, the application of all of the Internet of Things is still flourishing. Okay, then we will conclude our present. In conclusion, 5G wireless networks represent a significant technological advancement in the field of cellular communication. The development of 5G communication has been driven by the need for faster data transfer speeds, higher bandwidth, and improved connectivity. and has incorporated key technologies such as massive MIMO, small cell deployment, and millimeter wave frequencies. The deployment of 5G networks is expected to have a significant impact on the social and economic landscape, as it will create new opportunities for innovation and growth and provide new avenues for business to deliver innovative products and services. The integration of GFDM in 5G networks will provide a flexible and efficient way to support this diverse application. So 5G will have a brilliant future in our daily life, and it will undoubtedly play a significant role in shaping the way we communicate and interact with each other in the coming years. Okay, that's all for our presentation. Thank you for your watching.